Hey my dear students, welcome back to my YouTube channel. Now in this video we are going to start the new exercise 1.3. We have completed the exercise 1.2 in our previous video. If you haven't seen that, please go and check it out. Now without any further delay, let's get started. Let's move to the question number 1. Let's read. Express each of the following integer as the product of its prime factor. So the question says for the product of its prime factor. Okay, here what do you understand by product of its prime factor? So let's understand this. Product of prime factor. So here product means multiplication, prime means number that has only two factors, that is 1 and the number itself, like 2, 3, 5, 7, 11. All these are our prime numbers that has only two factors, 1 and itself. Now move to factor. Factor are numbers which when multiplied make your number. Okay, I hope you have understood till here. Let's do the sums. Here for finding the prime factor, first we divide this number 420 with all the prime numbers. Okay, one by one. First we check with 2, then 3, 5, 7, 11. All these numbers are our prime numbers. So one by one we divide this number with the prime numbers. Okay, let's start 420. If we divide with 2, then okay, now again with 2, here 105. Now 105 is not divisible by 2, then we check with 3. Okay, it is divisible by 3, so we take 3. 35 times. Now 35 is not divisible by 3, then we check with 5. Yes, it is divisible by 5, so we write 5 7 times. Okay, so now 7 divisible by itself, so we stop here. Okay, now we write prime factor. 420 equals to 2 into 2 into 3 into 5 into 7. Okay, we write like this, or you can, here 2 is 2 times, so we can write like this. Okay, 2 to the power 2. Okay, now 3 into 5 into 7. This is the answer. Okay, now question number 2. 468. Okay, so 468, again we first check with 2. Okay, yes, it is divisible by 2, so we write 2. It goes 2 3 4. Okay, now again with 2, 117. Now 117 is not divisible by 2, then we do with 3. Okay, 39, so again it is divisible by 3. Now 13 is a prime number and it is divisible by itself, so we stop here. Okay, so 468 equals to 2 into 2 into 3 into 3 into 13. So we write like this also, 2 to the power 2. 3 is also power 2. So this is the answer. Okay. Now question number 3. 945. Okay, 45. So 945 it is not divisible by 2. Okay, so we do with 3. Okay, 3 15. Now again with 3, Now it is again divisible by 3. 35. So it is divisible by 5. Okay, so we stop here. 3 into 3 into 3 into 5 into 7. Here we can write, here 3 is 3 times, so we can write 3 to the power 3. Okay, this is the answer. Now question number 4. 7 3 2 5. So you must know the divisibility rule. Here in this number the last digit is 5, so it is divisible by 5. Okay, so we direct divide with the number 5. Okay, if you divide we get 1465. Now again the last digit is 5, so we again divide with 5. 293. Okay, so now it is not divisible by any prime number, so we stop here. Okay, so we write 5 into 5 into 293. 293. This is the answer. Now move to question number 2. Determine the prime factorization of each of the following positive integer. Here also we have to find out the prime factorization. Same like this. Okay, 1 and 2 I will do for you. Okay, let's see. 70. Again we first check with 2. So here the last digit is 5, so we take with 5. Now this will divide with 11, so 187. Okay, now again with 11 we get 17. So since we write equals to 2 into 5 into 11 into 11 into 17, or you write 2 into 5 into 11 to the power 2 into 17. Again question number 2. 58500. Double 0. Again we with 2. 29250. Again we divide with 2. 14625. Again with it is not divisible by 2, then we take with 3. Okay, 4875. 1625. Now it is not divisible by 3, so we take 5. 3 2 5. 6 5 13. 2 into 2 into 3 into 3 into 5 into 5 into 5 into 13. You can see all these numbers are our prime numbers. Okay, so these are the prime factors and we express it as a product of prime factors. Okay, so 2, 3 to the power 2, 5 to the power 3 into 13. This is the answer. Question number 3. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So here we have to explain that why these two numbers are composite numbers. Okay, let's see. Here two conditions are given. One is this and the other is this. Now first let we understand what are composite numbers. Okay, so composite number means the number that has more than two factors. One is 1 and the other is itself. Okay, so first we solve the first one. If we take 13 common, 7 into 11, okay, plus 1, this will left. Again 7 into 11, 77, plus 1, then 13, 77 plus 1, 78. If we multiply 78 with 13, we get, okay, 1014. After solving this, we get the number 1014. Now we divide this number to find out its factor, so that we get to know that this number is composite number. Okay, 1014. So first 2, this number is not divisible by 2, so we check the another prime number with 3. Okay, 6, 9. 169 is divisible by 13, so we direct divide. So you can see here this number has more than two factors. Okay, all these factors are our prime numbers and it has more than two factors. One is itself and the other is 1. Okay, so we write, okay, since 1014 has more than two factors other than 1 and itself, so it is the composite number. So in this way you have to check whether it is composite number or not. Okay, now again we solve the second condition. 2, 6, 2, 3 into 2 into 1 plus 5. Again if we take 5 common, then we get 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay, if we multiply 1008 plus 1, then 5045. Okay, we get this number 5045 after solving this condition. So same again we divide this number with the all prime numbers for finding its factor. This number is not divisible by any other number, so we directly divide this number with itself. Okay, here also you can see we get more than 2 factor, okay, other than 1 and itself. So we write, since 5045 has more than 2 factors other than 1 and itself, so it is a composite number. Okay, so we have explained that how it is a composite number. Okay, check whether 6 to the power n can end with the digit 0 for any natural number n. If we take any natural number as the power of n, so the product of that, whatever may be the number, it ends with the digit 0. Okay, so let's check out. According to the question, if any number ends with the digit 0, then it should be divisible by 10, or you can say it will be divisible by 2 and 5. Okay, first, like if 10 factor is 2 into 5, so we will must divisible by 2 and 5. Okay, so we write, if any number ends with digit 0, then be divisible by 10, or in other word, it will be also divisible by 2 and 5, as the factor of 10 is 2 into 5. Okay, so 6 to the power, prime factorization of 6 to the power n is equal to 2 into 3. You can see in this prime factorization of 6 to the power n, here the factor of 6 is 2 into 3. So we write, therefore prime factorization of 6n does not contain 5 as a factor, hence 6 to the power n can never end with the digit 0 for any natural number.